All right. Hello, everybody. Hello, San Francisco. All right. So, whoops, I'm going to go through my slides in a second. But first of all, I'm really excited to see everyone here today. We've got another packed house here. We had like 550 people register for this, and I had a bunch of people like message me at like 3 p.m. They're like, "Hey, can I sign up for this still?" And I was like, "We're way overcrowded. We're way overcrowded." So, first of all, I'm really glad to see all of you here. Who has seen me before? Raise your hand if you've seen me before. Okay, a few people have seen me before. I'm getting more famous in SF. This is great. So my name is Yujian Tang. This is part of an event series that I do for OSS for AI. Our goal is to provide all developers with access to resources to understand, use, and contribute to the development and direction of AI. And so as part of that mission, we host a lot of events like this. And I also have this QR code sitting up behind me in the background here. This QR code, if you are looking for a job in AI or open source, and particularly if you're technical, if you're a software engineer, if you're a data scientist, if you're a PM, if you're an ML engineer, whatever, which I suppose most of you will be. Who's a software engineer? Raise your hand. Yeah, okay, cool, great. So if you're a software engineer, you want to work in AI or open source, and you're not happy with your current job, scan this QR code, fill it out. You'll get a notification, you'll get an email whenever we have people who are like, "Hey, we've got this job opening, and we're looking for someone to do blah blah blah." Okay, so let's see. Any phones out right now? Okay, I see some phones out, so I'm gonna just pause here and chill for a little bit. Okay, I think everybody's phones are no longer out. Oh, still a couple phones out? No? Okay. Everybody good? Everybody good? Thumbs up? Okay, looks like everyone's good, so we're going to move on. This slide is more important. This is me on LinkedIn, so go find me on LinkedIn. I have 8,900 something followers. I'm trying to reach 100,000 by the end of the year, so please help me. I'm missing 91,000. Hopefully we'll get there, but we never know. All you can do is really hope and do your best, right? Okay, so I see some people scanned it and some people didn't. Hopefully you guys will scan it later. This is the calendar. Actually, I don't really know why I have this slide, because I'm pretty sure all of you guys are subscribed to the calendar. If you sign up for this event, I think you automatically get subscribed to the calendar, so I'm just going to skip this. Okay, but this is the next event. So if you're here next month, how many of you people live in SF? Who is like based in SF? Great, so most of you guys are based in SF. So scan this if you're going to be here next month. We've got another event next month. And I believe this is the end of my slides. So before I get off stage and get our first speaker up here, I'm going to take a video. I want everyone to wave at the camera when it comes to you, okay? Ready this side? All right. Hello, everyone. Wave at the camera. Nice. All right. Great promo video. Okay. So that's pretty much it for me. Today we've got, oh, actually, no. You'll see me speak again later. But today we have two people other than me who are going to be speaking first. So we got Brian Johnson from Tavus, who's going to be talking about real-time conversational AI. When I first saw this thing, I was like, this is cool. This is like super cool. Like, you're going to love it. And then we also have Nick. Nick, where are you? Nick Shevchenko, who's going to come talk about Friend. I don't know if you guys have seen that. Who's seen the controversy around this on Twitter? Yeah, you guys have seen this? So I was really excited when Colin was like, yo, we've got this guy who's built this like thing called Friend. And I was like, whoa, that looks like the thing that's causing a lot of controversy on Twitter. Let's get him in. All right, Brian, come on up.
Hello, everybody. All right. Well, I'm Brian. I am a father, a husband, and an engineer. I work at Tavus. I'm a staff engineer. And let me see if I can pull up this slide. There we go. All right. Let's see. How do I do this correctly? Oops. Okay, that looks pretty good. All right, so I'm here today to talk to you all about conversational video interface, which is something that we just launched last week. I'm one of the engineers that worked on it. And I want to thank you all, first of all, for coming here to this talk. I'm sure you have a lot of different reasons for coming here. I'd love to know if anybody came here to hear about this, so hit me up afterwards if that's the case for you. So this talk is about one of my primary focuses in this project, which is the utterance-to-utterance speed. So that is the amount of time it takes from when you stop talking to when someone else in a conversation starts talking, all right? And then what were the challenges around achieving a lifelike, human-like utterance-to-utterance, and how did we do it? So that gets to the question of why is real-time conversational hard? And maybe you're wondering, what is real-time conversational? I'll get to that. But just imagine when you're talking to someone, that's a conversation. So if I'm talking to you and I say, hey, how's it going? If you wait that long, it's kind of awkward. But in a conversation where we're really vibing, you're going to respond like right away. And so what we aim to do was let me just say, I'll pass over this, was that we aim to create an API that lets you create a conversational replica of yourself that you can put out there, and it can have conversations with people on your behalf. All right? And so the goal here was to have a lifelike replica or a lifelike conversation. So that means it has to respond fairly quickly. The model we use under the hood is a proprietary in-house model that we've had for, really only since March. So it's pretty new itself as well. But it's completely built in-house. It's all proprietary. We have a machine learning team that is doing research and built this model. And we also just recently shipped a second version of that we call Phoenix 2, which is more advanced. So this model generates a video from audio. So it takes in a voice audio and generates a video. And then with that model, we've created the conversational video interface, which allows you to take that replica of yourself and put it into a web page, embed it in a web page, and allow that replica of you to have conversations, or let's just say, since we're all developers here, you can use this technology to allow your customers to put their presence out there, their replica, to have conversations with their customers. If that made any sense. Maybe not. It will soon. I hope. And I'll have some time for questions here pretty soon. Let's see. So the conversational video interface looks something like this. So let's say you are an online learning company and you want to put teachers out there. So you have a teacher in-house, and let's just imagine this woman in the larger picture is a teacher. She can authorize her likeness to be used with our technology, and then put out a interface on the web where people can join, like a Zoom meeting, with her replica, have a conversation, learn about the things she knows about, and it feels kind of realistic. Now you're going to know it's a replica, but it feels good. It feels natural. And so what we've worked on is developing the world's fastest conversational interface, which has a less than 1 second utterance latency. That's the time between the two turns of the conversation. It's the most realistic in terms of the naturalness of the conversation, but also the visual quality and the audio quality of the replica. So it really feels real. It's also plug and play. So we allow you to bring your own LLMs, your own TTS, pretty much replace any part of the pipeline with something you want. But then we also offer highly optimized versions of all of these things that you can use right out of the box. So the reason I'm having this talk is because of some research that I read about, that conversations that can be observed by a third party that look like the two people are vibing, that look like the two people are having a good conversation, tend to have an inter-utterance delay between the two turns of speaking of around 250 milliseconds. Now think about that. It's really fast. It's like somebody just Okay, so I'll mock it. So it's like, hey, how are you doing? Oh, I'm doing good. That's about 250 milliseconds. It's really, really fast. And when I first started working on this, that didn't make any sense to me. But as I've been thinking about this more and more over the past couple of months, I started to realize that is how we have conversations. Not only that, but we often actually interrupt each other. And so the research shows that the modal response time between two turns is anywhere between negative 1,000 milliseconds and around 1,500 to 2,000 milliseconds. So a lot of times in really good conversations, we're actually interrupting each other. We're starting to talk before the other person isn't done. That sounds kind of like wrong, but it's been shown to be true, not only in a single culture, but in all cultures. It's amazing. It's in all languages and all cultures. It's kind of a universal thing for humans. But the modal response time, the one here in the middle, is 200 milliseconds. And that's been shown to be what you can observe to see whether two people are sort of having a good time in their conversation. And so we didn't want to aim for that because it's pretty hard to hit, and I'll talk about why. But what we decided to do was let's go get below a second, because as you can see here, below a second is kind of starting to show up on the curve. So not only that, but for humans, thinking is part of the conversation too. We can't just blurt out something random. So if somebody says, hey, I'm having a bad day, and you say, great, that's not a good conversation. You got to actually have some time to think about it. And for humans, that time to come up with a thought is from after hearing someone is about 700 to 900 milliseconds. And there's kind of a disconnect here in my head. I'm like, okay, if we have to respond within 200 milliseconds, and it takes us 700 to 900 milliseconds to think of what to say, how do we do that? Anybody have an idea? Oh, you think ahead. You got to think ahead. So, but what if somebody's not done talking yet? Then what if the last thing they say is the most important? These are the kinds of questions that you have to deal with when you're thinking about a conversational video interface like this. But the good thing is that LLMs are pretty fast at thinking, and so that comes into play here as well. But we want to keep in mind that 200 milliseconds is actually the time when people are vibing. So if you're having a really good conversation, 200 milliseconds is what the inter-utterance delay should be. But if you're starting to get to know each other, if you're asking like a deep question that someone needs to think about, it might take 700, 800, 900 milliseconds for them to respond, because they actually have to think about what you're saying. So let me go step back a little bit and talk about what we needed to build. So what we wanted to build was something that when you sat in front of the camera, it looked like a human being. It looked like a person. It looked real. It sounds like a person. It sounds real. It can see you. It can hear you. It can have a conversation with you that's logical, based on the history of the conversation, and that it would respond proportionally to the way you're talking to it. So if you said something short, it's not going to go on a long rant. It's going to say, if you said, hey, how are you doing? It goes, yeah, I'm doing pretty well. Instead of, yeah, I'm doing pretty well. I had all these problems yesterday, but today was pretty good. You don't really, that's not a great conversation maybe. But we wanted to make it so it was proportional. It should also be interactive. That means that when you start talking, it needs to stop and start listening, even if it's already talking or mid-thought. Okay, so meet Carter, which is kind of like our internal name, which stands for Conversational Real-Time Replica. We've changed the name since then to Conversational Video Interface, but we kind of affectionately call this Carter. And Carter is a conversational replica, and I'm going to show you here.
What can I do for you?
I guess my audio is not hooked up, is it?
Experience. What do people tend to ask you? Thanks for joining me.
Can you hear that at all?
Enjoying the experience.
No.
Most people ask me about new feature
Okay.
updates. Or
Let me see if I can get audio going here real quick. Decimator? No. Decimator. I don't know. I'm going to try it.
want to know more about our AI technology. Some even just want to chat about their day and share a funny joke. How about you? What are you curious about?
I like jokes. Can you tell me a funny joke?
Here's one. Why couldn't the bicycle stand up by itself? Because it was too tired. Haha. How was that? Did I make you chuckle?
It definitely made me chuckle. A lot of LLMs know that joke. I wonder why.
I guess that joke didn't impress you with its originality. Well, I won't take offense. I'm sure there are plenty of people out there who know a million too tired bike jokes. If you want another one, or maybe something else, what do you say?
Oh, I definitely wasn't criticizing. I think you're very impressive. I'm curious what you can see also, as well as what you can talk about.
Al, thanks for the kind words. I'm glad to hear that. As for what I can see, well, I'm seeing a friendly person with a great smile and a background that looks like a cozy office or study. A warm and quiet space to get things done, or maybe just to relax. Is that about right?
That's definitely about right. I like warm, cozy spaces. Your space looks great. Who designed your space?
Thank you, I'm glad you like it. As for who designed my space, well, to be honest, I don't actually have a space of my own. I'm just a digital presence, so I don't need a physical office. But I'm happy to chat with you here and make you feel like you're in a cozy space.
Do you live in a simulation? Sometimes I think we all live in a simulation.
The simulation idea, isn't that a fascinating topic? I'm with you, it's definitely a possibility. I mean, who's to say what's reality, what's not? It's mind-bending to think about.
It definitely is.
The digital world.
Thanks for talking to me today.
We've reached the
Okay.
end of our conversation for now.
So that is, where did I go? Let's see, here we go. Yeah, so that's just a demo of how it works. You can go to our website right now, tavus.io, and try it out for yourself for free. It's there for anyone to try. We basically put it up on Product Hunt and got #1 product of the day, so thanks. Now, you've probably all seen audio to audio, right? Like the ChatGPT, like some of these other ones that are audio to audio. And the key distinction between what we're doing and what something like that is doing is that video is 10,000 times the size of audio. There's a lot more data to pass around. It's tricky in terms of bandwidth, and it's tricky in terms of latency to get everything to work that well. Fortunately, we had a lot of good partners. One of those partners was Daily, that helped us, Daily.co, that helped us with streaming. But we also had to apply some tricks and tips of our own just to get that data passed around on the inside of our conversational replica as well. And I'm going to talk about some of the tools we used to make that happen. So our goal was less than 1 second of utterance to utterance. And these are the 5 tools that we applied. These are kind of generic, and I didn't want to get into too much detail because these things change in terms of the implementation. And a lot of these should be pretty obvious to you, I hope. Things like streaming. So streaming is the concept of sending smaller bytes instead of sending larger chunks, and that allows you to get a faster time to first byte. Okay? Parallelism. Parallelism allows you to do multiple things at the same time. Using your resources as much as possible. So on any computer, you have a certain amount of resources available: CPU, GPU, RAM, disk, network, and you've got to be aware of all those things and know what you have available and know what you can use to your advantage. Memory. Memory is much faster than disk. And the closer the memory is to where you're using it for computation, the better, the faster. But oftentimes, the closer you get, the less of it there is. And then memory sharing. The more you can kind of share memory, the less you have to move things around. So let's talk about streaming for a second. It'll be way faster if we do streaming. This is kind of a recurring concept for us when we were building this. It was like, well, how do we get faster? We should do streaming. It'll be way faster. And a lot of times it proved to be true, even though it took quite a bit of trials and tribulation to get there. So in the example here where you're not streaming, imagine we're sending this like chunk of video over, and we're just doing one big chunk that we can play, and maybe even more than we can play at a time. It's slow. But if we break that up into smaller bits, and we know that we can start playing it before we get multiple frames of video, then we can send over these little chunks a lot faster. At some point, the overhead of sending these chunks is more than, it slows it down more than if we sent one big chunk. But the good thing is that we got enough chunks over fast enough to where we can start playing the video sooner, which improves utterance time. Okay, which is okay because we're faster to that first meaningful chunk, which means that we're faster in terms of response. All right. And it's something like n times faster up to a certain limit. So the smaller the chunks up to a limit, the faster the utterance to utterance is. And we're trying to get that down to like one frame of video that we render and send. And it's pretty challenging. We're getting pretty close, though. Parallelism. The next thing, the tool that we applied was parallelism. And that's the idea that what if there are multiple things that we can do at the same time, let's do them. We're running this on a GPU in the cloud, and we have so many processors. Let's say we have 10 processor cores, and we have like a NVIDIA A100 or something like that, and we have all this power available. Well, if it's just sitting there idle and there's something that we can do to get ahead, we should do it. And so this is kind of a rough look at the parts of a conversational replica or a conversational video interface on the back end. And these are some of the things that happen. So there's like capturing the audio stream. So you actually have to capture the audio stream, put it somewhere. Then detecting speech, detecting when someone stopped speaking, when someone started speaking, detecting or accumulating up that audio, transforming that audio into text that the LLM can understand. And then simultaneously, we need to be checking out the scene, asking questions about what's going on in the scene, and then sending that to the chatbot. And then the chatbot needs to send out its text, and then we have to figure out which chunk of text makes sense to say. And do we have to wait for a whole paragraph, or can we send, how much do we need to send? Then we have to convert that text to speech, and then convert the speech audio to video, and then send that back out over the network back to the chat room or the meeting room. So all those things have to happen within under a second. And a lot of that happens in parallel, actually. A lot of it happens, you need what the user said to transcribe it into text, and then you need the text to feed to the LLM for it to decide what to say next. And so if you were to just do that serially, your throughput's pretty small, right? So you're just sending this one little chunk of data through, and that's okay. But the problem is that if you had to wait for all that to happen and you could just do that, then your utterance delay is the time that it takes for all those to run. So that's where parallelism comes in. And if you can run all of them simultaneously, and you probably all know this, and none of these are magic tricks, these are all really basically good engineering, then you can do it faster. And it's nx times more throughput. And more throughput means that you can, that throughput and latency are different, but throughput at some point limits your latency. If the amount of data you need to send is more than your throughput, then you're digging into your latency at that point. So we decided to like go with a task-driven architecture where we have multiple different things running in parallel. That looks something like this. And it was way faster. Okay, the next thing that we ran into was that a lot of our stuff, a lot of our data that we use, our weights, our source material was stored in like S3. And then, we could download it from S3, but then it's on a disk, right? And then we're trying to get ahead of everything, trying to increase our throughput so that we don't dig into our latency at all. And so the faster everything can go, the better. But we started seeing that like parts of our inference started hanging or their bandwidth was a little too low, which started digging into our latency a little bit. And the more we dig into our latency there, the more we get behind in other places, and it kind of like, it just makes everything more complicated. It's better if we can just be faster. And so we started looking at moving all of that data as much as possible into memory. But depending on the model we were using, the memory, different amounts of memory were available. And so we had to kind of adapt as we went. Where we ended up at was that like the more we could put in memory, the faster it was. Very, very basic, very simple. And so here's kind of an illustration of what we figured out. Okay, so moving it into memory and then moving it to the process is really slow. But if you can actually put that source material in memory and keep it there, and instead of moving it, you just move the pointer to that, it's really fast. And so that little improvement shaved off like 1.5 seconds of utterance to utterance. So that's like CPU memory. Well, what if we took it further and we just kept things in GPU memory as much as possible? Like we have a multi-process system, but what if we could keep things in GPU memory? That would be great. And the reason that's great is that the further away you keep something from where you're using it, the further it has to travel and the longer it takes. And so if you can optimize things by moving your data closer to where you're processing it, you can act on that data faster and reduce your latency. And so we're just having things in GPU memory, and the processor over here is able to really quickly work through that data. And we ended up increasing our frames per second on our visual model by 4x there, bringing us up to like 95 frames per second, which allows us to get ahead. Because our video plays at a natural 25 frames per second. So now we're rendering the video almost 4 times as fast as we can play it. All right, so what's next? Well, customers that we've talked to so far, and Delphi is one of our customers, have asked for faster boot times. Now we have like several gigabytes of data that we have to make available on these machines, and we are trying to make this system scalable. We use a partner, GPU partner called Replicate for that, and in order to be able to make this scalable to say like 300 streams, we can't have all that data on all these machines because we don't want to pay for all these A100s all the time if they're not being used. So we essentially have to download that data onto the machines, which takes time. And so right now we've got our boot times down to around 10 or 15 seconds. And one of our goals is to reduce that down to about 5 seconds or make it instantaneous. So we're working on that right now. Faster utterance to utterance. Right now, our fastest utterance to utterance we've measured was 600 milliseconds. And I think that we have a way to get to 200 already. So we're working on that. Interruptibility, we already have that, but we can improve it. We can make it better, more responsive, more natural. Maybe some way of the bot not immediately stopping talking or something like that. And then more on the infrastructure side, things like events, observability, and an API. So we currently have an event-driven system where when the bot is doing things, like if it's speaking or listening, we send out an event to let people know. If when the bot joins the room, we send out an event. If there is any kind of issue, we let them know we let you know what's going on through an event. But we also have a REST API where you can interact with the system that way, and it's very simple, very easy to use. Okay, so these are the lessons on speed. So separate the steps thoughtfully. There was a point in time where we separated events too liberally, or separated processes too liberally, and that actually cost us in boot time. Even though it sped up our inference speed, but it wasn't really resulting in better overall utterance-to-utterance improvements. And so we had to actually kind of recombine some processes back together thoughtfully so that we don't have to spawn a new process, which takes time. Coordinating parallel processes carefully. When you do things in parallel, you need a way to like real-time coordinate between the different processes what's going on. Things like clearing the audio buffer when the replica is interrupted, or stopping the LLM from generating new tokens when the replica is interrupted, or deciding when to send frames that are silent versus when to send frames that are speaking. And then the last 2 things I talked about were moving smaller chunks and keeping things in memory as much as possible. And so ultimately, we were able to achieve anywhere from, like our utterance right now is about 600 milliseconds to 1.3 seconds. And the great thing about that is it feels kind of real. Like if you haven't tried it, give it a shot. It's on our website, tavus.io. It feels different. I think it does, even though I've been working on it for 3 months. And a lot of people have given us that feedback. I'd love to hear from you what you think. Do you think it feels different? Let me know. Hopefully it creates more of an authentic connection because you're talking to a person, you are seeing a person and they're responding to you, and it's more ergonomic, more natural, more kind of what you would expect out of a conversation. And we try to make it easy. I think we do make it really easy with our API. It's a REST API and quite easy to use. Some of the use cases are things like e-commerce. My dream is to have Michael Jordan on the Nike site selling you Michael Jordan or Air Jordans. And so as you scroll through, he has some agentic capabilities on the back end, and he checks you out, and he's like, yeah, I think you're going to like these Air Jordans. Let me take you to the page. And he brings them up, and he's like talking to you. He can hear you. You show him what you're wearing, and he makes suggestions. Or like, what about like a sales representative? Like a lot of times with the early cold calling or just follow up, it'd be nice just to have something that can go and talk to people in your likeness, gather information, figure out where they're at. They feel less pressure because they're not talking to a real person, but it's still you, and it's your authorized representation of yourself. And then things like customer tech support, where the person, it just needs to feel like comfortable for someone, where they don't want to they want to see someone and feel like a natural connection, because it's already stressful enough. And like seeing a person and hearing a person and having an interaction with a person kind of makes us feel better. And then things like tutoring and coaching. And the product's already loved by our customers. And so I think we really try to take a developer-first approach, and it's one of our key differentiators, that it's not just having a great replica, it's not just having a great conversational video interface or having a great API. It's the fact that we really want to listen to our customers as developers and move the needle for them. So we're not just trying to build the coolest thing, we're also trying to build the coolest thing that serves your needs and helps you build what you need to build. So that was my talk. Check us out here on this website if you want to try the demo. Feel free, and thank you very much. And I've got a little time for questions. So. Anyone have a question?
So I noticed a small thing.
Not this mic.
Thank you. So I noticed a small thing with the interjections, like haha, that definitely was like, it threw me a little bit for a loop. So do you have any plans to like effectively replace or maybe tune that specific piece more, or that one was really kind of threw my brain off for a second because the haha was very artificial in my mind.
Yeah, that's a good question. What he's asking about is right now, if the bot, I guess you heard it, laughs, instead of going ha 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 ha, ha, it goes ha 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 ha.
Objection.
Okay, because it's reading text. So yeah, we don't have immediate plans to do that, but we are looking at it, and it's something that we want to improve for sure. So that's coming up. Yeah.
Thanks so much. I noticed, like you had said, you do one frame at a time on the streaming, at least on the diagram. But at some point, there's like a cost benefit of like maybe giving a little bit more data to get that first response, so that it can be higher quality. So how did you think about that trade-off of like making bigger chunks that could be higher quality versus like time to first response?
Yeah, it's definitely a balance. So what he's asking about, it's a good question, is when you send. So he's asking if we send fewer frames to make the utterance to utterance or the latency better, do we lose quality? And how do we balance that trade-off? And so our Phoenix model is kind of unique in that it is designed to render a single frame at a time. It's using a context window to make that possible, but it's only it's capable of rendering a single frame at a time and have the same visual smoothness as rendering a batch. The issue is that when you start getting small, like I talked about, too small, the overhead of sending a frame becomes large enough to where you can't keep up anymore. And so we're really tuning as far as we can down to that single frame as possible, and we haven't gotten there yet. But we have a really strong bar on quality in terms of our vision, so we're really holding that line and trying to push as far on the engineering as possible to make that happen. And it really comes down to faster rendering. The faster we can render, the more we can keep up with that. There are a couple other tools in our tool belt too, but maybe I'll talk about that on the next talk. It's a more in-depth.
One more question. Anybody else? Oh.
Can you talk a little bit more about what you've learned about the pipeline for just focusing on the speech part, detecting that somebody's speaking and then what they're saying? But that's something that I've been really curious about is how do you, like there's obviously text to speech, but all the other components that go into that pipeline.
Yeah, so that's a good question. What he's asking about is what are all the components that go into not only figuring out what someone said, but figuring out like when they've stopped talking, right? When did they start talking? Like those things matter. And that was probably one of the more tricky parts of the pipeline because people stop and start talking a lot. You heard me just then, I took a pause, right? And so it's not only just about that part of the pipeline, although that has to be good. You've got to think about the rest of the pipeline. And how do you handle situations where you thought they stopped talking, you thought somebody was done, so you sent off some text to the LLM, and the LLM generated a response, and then it sent it to downstream, but then you start talking again. Did you have a back and forth with the replica, or are you still continuing your thought? And how do you deal with that? That's one aspect of it. The other aspect is around just the mechanics of dealing with noise is one of the tricky parts. Like noise in a noisy room like this, it's really tricky to, like if anybody was talking in the room and the microphone picked it up, then the auto speech recognition would start transcribing it. Well, things get really tricky when you do that. So we did some tricks around noise and trying to focus in on the user's voice. We've tried a lot of off-the-shelf stuff. We ended up kind of building our own thing that we feel like is better for now because it's very fast and it's also very good at figuring out when people stop talking and when they start talking. So I could maybe go into more detail about that later. All right, well, thank you, everyone. I appreciate you coming out, and thanks for the questions.
Thank you, Brian. All right, I left my drink up here last time. All right, thank you for that talk, Brian. Our next speaker is the man, the myth, the legend, the guy who made the Twitter controversy for Friend, or at least part of it.
All right. One second. All right. Yeah, sorry for this putting like two variables on me. Let's see how tough is the crowd today. I see so many people, and I think I have never seen so many open source developers in my life. Can you please raise a hand if you ever did at least one commitment to open source repository? I did it. Damn! Wow! And now I want you all to clap to yourself because you are all great. Can we do that? Thank you. If not you, in this room, open source would die. So thank you a lot for that. Now, let me show you something pretty interesting, which is probably you will not see anymore because we are a hardware product, not software, as you have already seen many, many times here in San Francisco. Before I tell you what I'm building, let me tell you what will happen in roughly 1 hour from now. In 1 hour from now, you're all going to stand up. You all will go all around there in the kitchen or in the cafe, and you will start talking to each other. Not only that, but you will also see somewhere around 20 presentations and demos of 20 different products within the next hour, and you probably will struggle to remember, like, you know, what you actually have seen 1 hour later. And tomorrow, once you will like, wake up, you will see something like this on your phone. We have all been there. We all know, like, networking events, San Francisco, too many of them. Like, I mean, what happened? You probably don't even remember my name anymore, and my name is Nick, by the way. And this is exactly what we are building, and this is exactly the product that, the problem that we are solving with this. This is Friend. This is open source necklace that you put on your neck. You go to any event, you just go about your day, and it will remember who did you talk to, what did you talk to them about, the key points, the most important stuff from your conversations. Do you need to follow up with the people or no? Was the conversation actually interesting? Should it be remembered or no? Not only that, it will also automatically put event in your calendar. It will create action items for you and do much more stuff than I just told you about. And yeah, instead of me just like telling you like what is this and how does it work, let me just show you. Let me quickly pull up my phone, which is connected. Okay, cool. You should be able to see. Oh, you also see my presentation. No. That's not supposed to be that way. But anyways, so yeah, this is my phone. It is connected to my computer to show you. And these are all my conversations that I have done with other people like during the past couple days. You probably wonder how does it look like. So let me just open, let's say, this one. I discussed an integration of Apple Watch because we want to integrate our product with Apple Watch. And it automatically created action items for me. And not only that, I actually discussed this with my co-founder, whom I really trying to convince to do climbing because, I mean, what else you can do in San Francisco? And it automatically created an event for me and put it in my Google Calendar to do a climbing test together with him. Not only that, but there are also hundreds of different plugins that are built by really amazing and great people like you. For example, there is a plugin called Conversation Summary that actually does the summary of conversation based on the custom prompt. There is also a plugin Insight Extractor, which is like a little bit different and actually helps me to remember the most useful and interesting stuff. Besides that, there is obviously live transcription of each conversation, so you can see it inside. Let me just show you. Like, for example, here, it automatically divides it on different speakers. You will also be able to assign names to people later. You can do it right now already, but you'll be able to do it with other people and will remember by names, not just speaker 1 to speaker 2 and so on. All right, there is a live transcription and there is also a chat. And what is this chat? Like, how is this better than OpenAI and like Claude and so on, which you have probably tried yourself? And the coolest part is if, for example, I ask a question, hey, what did I do 2 weeks ago? Or like, what did I do yesterday and stuff? And it will give me like exact outline what I have done because it knows everything that happened during my day. It knows who did I talk to, it knows when did I talk to people and stuff like that. For example, here I was discussing like house management stuff, I discussed Apple Watch integration and so on and so forth. Oh, damn, my iPhone got locked. No, let's fix this. All right. Yes. What else? Oh, someone actually tried to break a prompt and asked what is my credit card information. It was my friend, but yeah, I never actually said it in real. Not only that, but you can also customize how your AI works with you. For example, if you are in the process of dating, and probably you are since you're in San Francisco, and it's very hard here, you can enable a dating coach that will actually help you to like do that later for your conversations. Or you can enable like a Paul Graham plugin if you're a startup founder, it will give you feedback and advice that will help you to create an actual cool company. Okay, enough of this, probably boring. Let me just show you the coolest part. This is the most interesting. So we have somewhere around like a couple thousand developers in our open source community, and they built all these amazing plugins that can customize your experience any way you want. You can connect it to 7,000 different apps right now already with Zapier, or you can just do like your own plugin that you can do probably within like 1 hour or so. And my co-founder in a couple minutes will show you how easy it is. And let me just quickly get back here. I just have a couple more slides and we'll just go from there. Okay, So yeah, this is Friend. It's fully open source. It's private because you can record just yourself, or you can customize it to record like only people you want to, which is sometimes actually might be a little bit tricky, but anyways. And it works at least 5 days on single charge. In 4 months, we became 4,000 developer community in Discord, 7K stars on GitHub. We did a successful Kickstarter with almost 1,000%. We delivered 3,000 devices to people like you here in SF, and we launched 3 products, which is Smart Glass, Necklace, and a pin. The last thing is we recently introduced the new version of our device that has onboard memory, speaker, vibration, no vibration, speaker and onboard memory, which can simulate vibration as well. And we also built smart glasses, which you can see here on the picture right. It just attaches as a clip to any glass you're currently wearing. And we named this all together as OMI. And I know that it's like kind of hard to get to the new name and stuff like that, which is why we did a very, very small, some kind of maybe like not a contest, but like a giveaway basically to celebrate this new thing that happened in our lifetime. So we are giving 10 devices for free to random people who star the repository. And we'll do that on Monday, the next Monday, so basically in 1 week from now. And our repository is actually here in this GitHub link. Not only that, so if you, let's say, like and start the repository, you'll have like a high chance of getting a random device. But if you don't like randomness, you can just do at least 1 PR, 1 commitment, 1 pull request, and we'll also give you a device for free. We'll just ship it to you anywhere you are. Just scan this QR code, and now, let's just do something. I want you all to welcome my co-founder on stage, who will show you how easy it is to build a plugin. Joan? Okay, so we don't have a microphone holder, so I would really ask you to be quiet because Joan will just do live coding and we'll try to scream as he can. Get some help with the screen. We see it here, but we don't see it there. Sorry, Fox. No. I don't know. Should maybe try this one? Try this one. Not even a demo. Yeah, let's clap.
Nice. All right, guys. So we will build like a super simple demo. Basically, I'm pretty sure you all seen the other friend, right? Well, Nick explained that once a memory creates, you can do anything with it, right? So you can get the data, put it anywhere, do anything you want with it. So what we'll do right now is just get the audio from once a memory creates, and use Llama API to like trigger some sort of emotional support identification. That makes sense? All right. So here's like a super simple setup. So, let me first, it doesn't appear. Let me first show you how you enable developer mode in the device. So pretty much you go here, go settings, enable developer mode here. And for testing this, what we'll do is to set up our webhook URL. So from the app, you can trigger webhooks. There are 2 ways of triggering them. The first one is once a memory creates, and the second one is on real time. So every segment that arrives to the app can be sent to a webhook, so you can also trigger actions in real time, right? So we'll do right now on memory created. Once you set it up here and save the settings, you pretty much, like how we can trigger it, well, it will trigger once a memory creates, but the way to trigger like for quick testing is pretty much you go here to settings, here to the top right icon, developer tools, and trigger memory created integration. So yeah, so let's build that endpoint, right? Let's get started, like just some basic imports. Let's just import here, well, basic launching stuff. We'll send the audio file on base64, so you gotta decode it to a file. And then here is pretty much just like an util function for waiting while Llama API process the audio file. Oh, yeah, all right. Can you see it there? Yeah. Better? Yeah. All right. Yeah. Super simple request here, so we'll use this in a second. Yeah, so let's get started. Let's build like our router with fast API, router.get, .post, sorry. Audio, emotional or something, def, and let's receive the data here, which is of memory type. I will show you the memory type in a second. So you can see like all the memory fields that you have available to develop whatever you want. So yeah, we have like created at, started at, finished at, all the segments that happen there. If you are using OpenGlass, you have access to the photos. So you can do also anything you want with the photos. The recording file, the structure is pretty much like a summarization of it. So yeah, we have our router. One sec. Great. And what's the key here? Whatever we return here on message, on a super simple response object, like hi, whatever, it will be triggered as a notification for the user, right? So let's just test this simple example and see what it triggers. So let me go back to Android Studio, here to the app, and I probably wrote the API, the webhook URL wrongly. One sec. All right, so it's audio / emotional sec. Great. And then let's just trigger the webhook call. Oh, okay, let's run the app. One sec. Nice. In the meantime, let's finish building the router. So very quickly here, let's just copy this part of the code, initiate the Llama API call. Once the jobs get started, let's just wait for the job completion. Now let's get the predictions data, which is like pretty much the transcript from Llama plus the predictions of emotions. And finally, just a super simple prompt that says, hey, make the user smile or something from notification based on the conversation and the emotions that it triggered, right? So let's also do that part. Let's just fix the imports. Right, just fixing some things that were wrong in the Jupyter Notebook. Okay, now let's import HTTP exception. Let's go. And yeah, let's just return that result string in the payload. Message equal result. So this is pretty much it. Let me just now just show you how it works. Okay, Android Studio doesn't work today. There are a lot of examples in the repo that you can check out. There are examples for like Notion integration, so you can export all your memories to Notion, or even like have a database in Notion that lets you create inside friend, like memories, conversations, or anything. There are also plugins for glasses, where all the images like count the number of faces or detect faces on people in the photos that it takes. What else? Okay, it's all right. Just a few more seconds. Shouldn't take long. right, finally. And yeah, this is like the endpoint we already have it set. Now let's just trigger the webhook. Whoop. All right. And test trigger memory integration. It's a result equals true. It's pretty much that the recording file base. All right. Do you have more time? Yeah, okay. So let's just trigger like a sample memory. Let me just get it from here. Capture, oh fuck, it's not capture. Let's just make a random conversation with Hume. Hi, can you speak with a lot of emotion, a lot of joy?
Hey there. Why, of course, my friend. I absolutely adore injecting bubbly energy and palpable delight into our conversations. And every word is an opportunity to express the sheer elation of being alive and present with you in this very moment. I'll do my best to radiate cheerful vivacity from the deeps of my soul. This world is...
All right, that should be enough. Let's see what it triggers. So, okay, put this here. And now when we trigger this thing here, it will send the recording file base64, and it should start the processing with Hume. Yeah, in progress, completed. And it didn't trigger anything. All right. Let's just see what the prompt responded here, or do we have more time? Kinda. All right.
Demo gods are not in our favor
Yeah.
today, but we'll...
Probably there was not enough context in the conversation, so let me just. Yeah, I have a hunch that there is something on here failing.
One more minute.
All right.
All right, it didn't work out. Well, that was 95% of it. It should have triggered. Yeah, it's super simple to do, really. Like, we almost built it in 10 minutes. That's fair. Check out the documentation. There's a lot of examples on how to build plugins with Friend. Yep, that's pretty much it. Thanks.
Thank you. Cool. Thank you guys for that talk. Oh, do I need to pick this up? All right. All right. All right. Oh. No, I don't talk into that mic. I talk into this mic. I guess I talk into both. All right, we'll have a bathroom break really quick in like 15 minutes, I swear. But we are going to take a look at Llama 3B and Mistral 7, Llama 3.1 versus Mistral 7B for RAG. So I'm sure this is a talk that you guys all came for. So this is my talk. So this is the most important talk of the night. I haven't given a tech talk in a while, but sometimes you just kind of got to do one of these every so often so people still remember that you can. So that's what this is for. So today we're going to be talking about Llama 3.1. I'm using the 8B version, and we're using Mistral 7B for RAG. And we're really just doing a toy presentation, so don't take any of this like very seriously. Take it with a grain of salt. Kind of use it as like a, hey, this is like a way that we can compare these models. This is not like the end-all, be-all of these models. But before we get into this, oops, okay. I want everyone to kind of do a little bit of interaction here. Who thinks that the 3.1 8B model was faster? No one thinks it was faster. Who thinks Mistral 7B was faster? All right, so clearly 5 people are raising their hands. Come on, we're gonna redo this, okay? Who thinks that Llama 3.1 8B was faster? Raise your hand. You don't have to scream and clap, but thank you, Yi. All right, so that means the rest of you guys all think the Mistral 7B was I'm going to repeat this until everybody raises their hand, or at least a large portion of the audience raises your hand. Raise your hand. Go. Okay, Llama 3.1. Faster, faster. This is faster. Okay. For RAG, faster for RAG. Yeah. Okay, Mistral 7B, raise your hand. All right, okay, a good portion of you are raising your hand. Those of you who didn't raise your hand. I see you guys, all right. So we'll just do a quick tech review, right? So you guys have all built RAG. Who's built a RAG application? All right, great. So you guys kind of know what goes on in a RAG application, right? The whole idea is that all you're doing is you're giving your data to an LLM, and basically what you're gonna do is you're gonna take an LLM, that's your core piece of your RAG app, you're gonna take a vector store, you're gonna take an embedding model, and then you'll probably use some sort of frameworks. So later we've got a demo from someone who used to work on Llama Index, which is not the framework I use for this. So a little bit of information about Llama 3.1. Came out July 31st. There's the 8B model, the 70B model, and the 405 billion parameter model. We're using the 8 billion parameter model. The main reason for this is because this is like a similar in size to the Mistral 7B model. I don't want to compare it to the 405 billion parameter model. That doesn't seem very fair to me. And then the upgrade from Llama 3 is that now it has 128,000 size context window. So this is just quick background on Llama 3.1. They spent a lot of money to build this. And Mistral came out about 9 months ago, September 27th. Actually, it's August, so 11 months ago. September 27th, 2023. And this has about 7.3 billion parameters. They say it has a 4,000 token sliding context window. Basically, that means it can handle 4,000 tokens at a time, but that doesn't mean it can only handle 4,000 tokens. At least this is the claim. Okay, so here's what we did for our experiment. We took a basic RAG app, and we put in a bunch of Wikipedia cities. And I used OctoAI for the LLM because they provide access to a lot of open source LLMs, and they also give me a lot of free compute. And I used Face. Who's familiar with Face? Facebook AI similarity search. A few of you? Okay. Who's familiar with vector databases? Most of you are familiar with vector databases. Great. If you're familiar with vector databases, you should know this vector database. Face is like, I would say like the OG kind of like vector database, right? And then I use Hugging Face for my embeddings. Everyone here is familiar with Hugging Face, right? Raise your hand. You know Hugging Face. Okay, great. And then I use, like I said, not Llama Index. I use LangChain. But don't worry, I am in the process of building an example with Llama Index. So next time, hopefully, you can get Jerry to come out, and I'll show him my example. And I've asked 9 questions. And these questions are just, like I said, toy questions. 2 of them are impossible questions. And then I did evaluation with Arise AI. I think Arise also hosts a lot of events out of GitHub. So, yeah. Okay, so, okay. Yeah, so I got 10 minutes, so I'm gonna walk you through the code. All right, here we go. Let's see, RAG cookbooks. All right, everyone can see this? Thumbs up, everyone can see this? You can read this? Okay, cool. So I'm just gonna quickly walk you through the code. It's almost the exact same code. I'm literally just using a different model. So first, we're gonna install a bunch of things from LangChain, and then we're gonna install Arise, and then we're gonna install OpenAI. And then I'm gonna get my API tokens here. This is just environment variable kind of stuff. If you guys are familiar with environment variables, you probably know how to do this. Here, all I'm doing is I'm launching Phoenix. So Phoenix helps me do tracing, it helps me do evals, it helps me do all this kind of shit. And yeah, all I'm doing here is launching it. I'm launching it for LangChain. I'm ingesting some data. Okay, so this part may be interesting to look at, right? So what we're doing here is we're opening this entire directory. We're gonna read the entire directory. The directory is a bunch of text files. Here's an example of what these text files look like, right? They're just a bunch of text. Nothing special about these files, nothing fancy. They're all Wikipedia. I just scraped Wikipedia. So we're gonna read these in, and then we're gonna do this thing here where we chunk it. So everybody here, everyone's familiar with chunking? Chunk size? Well, you will be after the demos. So I've set these all at 800, 200. Why did I set these at 800, 200? It's just a random number I picked. Okay, and then once this is important. So separators are actually quite important because if you mess around with the separators, you'll find that using different separators will give you different actual chunks. And sometimes what you'll end up with is you'll end up with these like really, really big chunks if you use like rare separators, like a double new line. That was what I originally went with, and I had chunk sizes in the 2000s, and I was like, this doesn't seem very fair. So I use a custom separator here, and then basically all I'm doing is chunking these up, storing them into a vector database. And like I said, Hugging Face embeddings. Hugging Face, we're creating a vector store from Face, right? Facebook AI similarity search. We have 543 entries. So like I said, very, very small example. In production, you will probably be looking at hundreds of thousands to millions at the very smallest. And then all we're going to do here is we're going to create some way to search the data. So here you can see I'm using Llama 3.1, 8 billion. And it's going to give me a max tokens output of 1024. I set this temperature to 0, just so that we kind of get a more repeatable, deterministic, ish, repeatable kind of output, okay? So that's kind of what this is for. We create a retriever, and then I say, hey, you're a helpful tour guide. You're going to get some context. Answer the question, okay? And then I give it some questions. I give it some context. And then I read through these questions. So we're going to read through 9 questions because I still have time. So I have it list the cities from the oldest to youngest: Paris, Berlin, San Francisco. And then I ask which historical monuments should I visit in Cairo. I ask if Chicago is more or less populated than New York. I think most of these 3 questions you guys probably all know the answer to. And then I ask it to compare and contrast nightlife in Houston and Moscow. And I ask about which city has a more active tech scene. Oh, I really should see if I can run this live. Okay, I'm going to try to run this live and see if this works. This might take a bit of time, so I'm just going to loop through this. All right, hopefully I didn't break anything here. Let me see. It seems to be running. Okay, so I ask it about San Francisco or Lisbon, which has a more active tech scene. So I think you guys probably know San Francisco is probably more active than Lisbon. Which city has a more active financial sector, London or Boston? I don't know the answer to this one, but I think it's London. Where's the, oh shit, I broke something. Okay, well. Uh-oh. All right, well, I broke something on this, so that's embarrassing, but you'll see the results that I got last time anyway. Where is the Eiffel Tower located? Everyone knows, Paris, France, right? And then the last 2 are impossible questions. So there are some questions that your LLM is never going to be able to answer correctly. And these are example, well, okay, maybe not the last one, but the second to last one. When should I visit the Empire State Building in Houston? There is no Empire State Building in Houston. So your LLM will never be able to give you a correct answer to this question. And then the last question is, who is Yujian Tang? So I'm not very famous yet, but at least not according to Llama 3.1 and Mistral's cutoff dates. Nobody knows me yet. So let's see if I can get this to run again this time. If not, I'm just going to show you the results. All right, so there's, okay, let's see. There's a couple evals that we're doing here. So hallucinations. Does anyone think which, let's see, raise your hand if you think 3.1 had more hallucinations. I see one person with like a very like timid hand raise. Yes, yes, raise your hand. Be confident, okay? Yes, have some belief in yourself, guys. Come on. All right, who thinks that Mistral had more hallucinations? Raise your hand. Ah, there we go. Here's some people with more confidence. So the people who don't like Mistral have more confidence. That's what I've learned today. All right, and then QA correctness, whether or not it answered the question correctly. Who thinks that 3.1 answered more questions correctly? Okay. A lot of you. Who thinks that Mistral answered more questions correctly? No one. Wow, okay. Geez, I hope Sophia is watching this. All right, relevance. I don't remember all the relevance metrics, so I'm just going to go towards these metrics. So these are the results for Llama 3.1. I ran 9 traces, which is, like I said before, this is like a very, very small number of traces. When you are really running this in production, you're going to want to run like 9,000. Okay, so this was 9 traces, 29,656 tokens, a P50 latency of about a second, a P99 latency latency of about 2 seconds. Remember what you said earlier about which one you thought was faster. Remember what you said, because I don't. There's too many of you for me to remember. But remember what you said and compare it to the actual results. I use the same internet on both of these, so hopefully it should give somewhat similar results anyway. Hallucinated about 22% of the time. That's 2 out of 9, which makes sense, right? The last 2 questions that I asked it could not have answered without hallucinating. QA correctness, so it was correct most of the time. And I don't actually remember what these relevance metrics mean, so I'm not going to go over them. All right, so before we go into Mistral 7.3b's results, does anyone want to change any of their answers? Does anyone now think that Mistral might have been faster? No one wants to change their answers. All right, we're going to go look. So you'll see Mistral 7b, very similar, very, very, very similar profile. So it's been about, remember, they spent about 9 months training Llama 3.1, and it gets a very similar result to Mistral 7b, which was released in September of 2023. So who thinks that that was a good use of a few $1 billion? I don't know. I mean, you can see the hallucination and correctness almost the exact same. I would say it looks like Llama 3.1 is a little bit faster at 50. And that's about it. Mistral 7b uses a few more tokens. So I've got about 2 minutes left on stage before we do a bathroom break. Does anyone have any questions for me? Oh, yes.
Were you running the quantized version or the full version?
I was running the full version. Okay. I was running the full version. The person behind you has a question.
Why didn't you let us say a tie?
What?
A tie between the hallucination and the QA correctness.
Why do I think there's a
No. You gave us
why do
a
I think there's a
binary
tie?
option.
Oh.
I was going to
yes,
answer
because
tie.
I specifically wanted you to answer incorrectly so you would feel bad about yourself.
Okay. Well, I don't. So thank you.
I just wanted to see what people would do. I forgot that the tying was an option. That's why.
But you knew it was a tie.
Well,
okay, sorry.
I forgot.
Apologies.
Can you pass the mic to this guy?
Thank you. What's the probability that the hallucination and QA correctness evaluations didn't run a second time and you just have a stored same value?
The probability is 0 because I rebooted my Phoenix instance. Yes. Arise Phoenix, not Phoenix, Tavus Phoenix. We should really do an event together so we can have like a duo Phoenix event. Okay.
Can I ask one follow-up? Why do you think it is that they tied?
Why do I think it's a tie? Probably because I only asked 9 questions, 7 of which I feel like it should have answered like no matter what, and 2 of which I was like, these questions are impossible. It should be wrong all the time. So actually, it shows that both models are very high quality because they answered all 7 questions that you would expect it to get correctly. Any other questions? We have time for like one more question. Oh, yes. Can you pass the mic up there? I love to see the audience working together.
2 questions. First, regarding the latency, how much do you feel like the time differences are due to like, I take it like these are hosted models on like...
Yes, so these are hosted models. So I have 0 control over latency.
Yeah.
The only thing I would say is I tested both these on the same internet, and it looks like the latency at P99 is actually very similar, right? This is 2.0. This is 2.04. This is 2.08. They're basically the same.
Yeah. And the second thing is, do you remember like what the models answered for the last 2 questions, like some sort?
Do I remember what?
What the answers were, like the responses for the last 2. Like, was there a difference in the answers?
The answers were pretty similar. All right, that's my time. The answers were pretty similar. Mistral was a bit longer, but I don't remember all the exact answers because, well, I was hoping to be able to run it live, but clearly I had a bug in my code and it did not work. So, all right, guys, let's take a bathroom break. Let's reconvene in about like 10 to 15 minutes. We've got 14 pitches. There was going to be 15, but someone had to back out at the last minute. So there'll be 14 pitches later. Oh, that's a good question. I have no clue.
Because maybe
I'll have to-
Mistral wrote longer answers.
Yes, yes. I'll have to check with the Rise because they have probably have.
I just feel like it should be faster since it's a bit smaller, and I'm also biased to Europe. So
Oh, okay.
Go Europe.
How's it going? Yeah, I'm gonna put this. Daniel Bernardi. Daniel Bernardi. Daniel Bernardi. Daniel Bernardi. Tool House. Daniel Bernardi from Tool House. Tool House. Daniel Bernardi.
Yeah, right over there.
Oh, right there.
Yeah.
Tool House guy. All right.
He's purple hair, short. There. He's right there.
Talking to Colin.
Now he's just over there.
Daniel Bernardi. Oh, okay.
Yeah. By the way, sorry if my question came off as like aggro. I was just like, I totally, when I see a coincidence like that, I'm just like, I would totally do the same thing.
It's totally
Okay.
cool.
I wasn't sure.
I'm happy to field any questions. It's always fun.
Yeah, I thought the talk was really fun.
Oh, yeah,
Yeah.
thanks.
You're exceptionally comfortable, like talking to like a large group.
Yes, I've
Yeah.
done it many times.
Yeah. I can tell.
Okay. Andrew. Armin Hamra. Armin, are you Armin? No. Armin Hamra. Are you Armin Hamra? Armin, oh, you're here.
I'm here.
Dan. Shut up. Koi? Where did you go? Koi? Koi? Okay, Julian Sachs. Aditya Rohit. Aditya Rohit. Cole got dank. Cole got dank. Cole got dank. Sarab Mishra. Sarab Mishra. Oh, you're Cole. Okay. You're Cole. Okay. Sarab Mishra. Oh, you're Sarab. Okay, Sarab Panda. Sarab Panda. Oh, you're right here. Anish Chopra. Anish Chopra. Anish Chopra? Anish Chopra. Oh, you're here. Okay, good. Okay, Yi, I saw you, so I know you're here. Thomas Smoker. You're here. Thomas Smoker. You're Thomas Smoker. You're his co-founder. Okay. Okay. Everybody has 2-minute demos, right? You are you Armin Hamra? Okay, you are. So Daniel, you're first. We'll try to get started in about like 4 or 5 minutes here. I'm going to start rounding people up, and then we'll get you ready. All right. Everybody's had a chance to go to the bathroom, get some water. Is there anyone in the back? All right, people in the back, just so you know, the 2-minute demos are starting. So if you're back here and you want to see the demos, get out of here. People playing ping pong, stop playing ping pong. All right. All right. Hello, everyone. Clap once if you can hear me. Clap once if you can hear me. Clap twice if you can hear me. Clap 3 times if you can hear me. Clap 4 times if you're standing up and not listening to me. All right. Yes. Yes. Thank you, Colin. All right. All right, guys. We're going to have our demo starting. So those of you who have not been here before, we run our own version of America's Next Top Model. And this is it. So we've got 2-minute demos. And there will be a timer right here that lets you know once you start. There will be 2 minutes. And yeah, Daniel from Toolhouse, come on up.
Hey everyone. Thank you. Let me get set up. All right. Oh, thank you. Amazing. Okay. We should be all set. You'll see in this. Perfect. So it's 2024 and LLMs cannot tell the time just yet. They can't really send the emails they write. Let's fix that with this thing, Toolhouse. Toolhouse is the first marketplace for AI function calling, and it basically gives your LLM, whatever LLM you're using, the ability to just extend its capabilities with just 3 lines of code, literally. So with Toolhouse, you install these extensions just like you install apps on your phone, and we just remove 3,000 lines of code or more, and we turn it into 3. Just 3 lines of code, I swear. Any LLM, any framework, and all these tools run in the cloud, and it's optimized for speed and accuracy. By the way, before I forget, phones up. If you want to join right now, $150 worth of credits just for you. All right. So with Toolhouse, you do basically something like this, where you don't have to build any other code or extensions right there. You just import the Toolhouse SDK, then you pass the tools directly into your function calling, or if you're using like LangChain or others, you just do whatever you do usually, but you don't need to write and execute those tools anymore because we take care of the rest. You're streaming, that's fine, we handle that. You're switching LMs, that's fine, we handle that. So don't worry about this. I'm going to show you how to basically build a virtual sales development representative that knows about Toolhouse with this code, basically. We're going to use Streamlit. Okay, so again, if you want to use our generous offer today, I prepared some prompts, so I don't have to fumble while I type. I'm going to ask the LLM to get the contents of Toolhouse and summarize its key value propositions. And it's probably going to fail because, yeah, we don't know what Toolhouse is. Let's fix that. So we go on the tool store, and we get a scraper, get page contents. I'm going to use this thing called memory. Ooh, already.
Your 2 minutes is up.
Ooh.
Your 2 minutes is up. It was fast. It's a lightning round. All right, let's see. Next person up.
All right.
All right, Andrew. You got 2 minutes. Andrew Van Beek from DevDocs. Andrew, grab the mic.
Howdy. How's it going? Can you guys see my screen all right?
Zoom in a little bit.
Okay, let's do this full screen. Gotta use a GitHub code space at GitHub, am I right? Good thing I'm not a speaker, professional speaker. Okay.
Zoom in.
Oh, zoom in. So we're working on like DevDocs, which is basically AI-powered developer documentation. So here is basically like an example of like our own documentation site that's actually like generated with like our own like AI. It basically looks at your like code base and then generates your docs so you guys can focus on shipping. So what I sort of want to do here is basically sort of show a live demo of this. So let's say, and can you guys hear me all right? So I know time is of the essence. So here I'm actually signed in with like the DevDocs like extension here. I can actually just select my team, which is Sprite AI. So here I can generate two types of documentation. So one is like onboarding documentation. You're a new engineer on my team and you're trying to learn how to contribute to this code base. So here I just hit Shift Command D, and then this is actually going to generate documentation to a little markdown folder called like DevDocs here. And you can sort of see the documentation is generating in like real time on this actual code file called index.js. And then if you're ever curious on it, you can always just like right click on this file. And then this will open up like a little editor on like all the notes on that actual specific like code file or directory. So if you're ever curious on like the actual documentation of a code file, you can do it like so. Now let's just say you had the opposite use case of like, hey, I'm building an SDK, an API, some sort of product, and I need public documentation. You can actually just hit public external docs. And what this is actually going to do is generate documentation to a markdown site very similar to the documentation site you guys saw at the beginning of this demo. So if I actually go to Sprite AI DevDocs, which is, you know, my fake SDK, you can actually see there's actually a now timestamp on my GitHub repo. So here, I realize I've done this demo a lot, so there's like a lot of folders. So I was like, you know, like, oh, what's going on? And then, yeah, that's pretty much it. You can see the documentation generated there too. Thanks so much.
Thank you, Andrew. All right, next up, we got Spike Intelligence from Jason Liu, who's very well known for breaking models at hackathons.
Let's see if this works. I'm not on Mac like y'all. Okay, there we go. So this is actually running. I'm going to do this lightning quick. So this is running a couple of blocks from here. It's Enterprise Survivor Security Suite. Now, everybody, shout out what you see wrong. Real quick. Anybody see anything wrong?
I don't know.
Okay, doesn't matter. Cross-site scripting. So we're going to go ahead and go to text generation web UI, and then we're going to use this model. And then this basically says XSS attacks are basically this is running literally 3 blocks from here. So this is currently ng-rock up top. Okay, so this, you know, whatever, it'll give you the fix. And then let's take a look at this slide. So this one we can take a little bit of time with. This one's pretty obvious in my opinion, but go ahead. Anybody got it? Yes, SQL injection. There we go. So let's go ahead and run this one through. So basically, this is all literally running on my personal home server, and you can see it on Twitter. This is a very effective method in my mind. So actually, I was very surprised. I actually have more time than I thought. But when I prompted Claude 3.5 Sonnet today, it didn't catch this one specific SQL injection, which I was extremely surprised with because it gave the improvement. So also, if you can tell, cursor execute, there's a little bit of improvement of 12% about improvement in speed. But that's just a side effect, you know, that I want to make code better. So that's generally, I train on a lot of good code, train on a lot of bad code. So that's what, this is our, pretty much our product. And it's API only right now. This is pre-alpha, but it's getting better and better and better. And it seemed to, at the very least, surpass the existing large language models that are available through API. Thank you for all.
All right. Thank you very much. All right, next up we have Element from Armin Hamra. Now you guys are familiar with the pacing, so.
Hi, so I'm Armin and is this working?
I hope so.
I'm Armin, and I'm from Element. We are an AI speech synthesis company, so we want to bridge the gap between humans and machines, and we want to do this through speech. We feel like there's a lot of investment and innovation in the text space, or in the text space, as well as like the video space and whatnot, and speech is a pretty untapped field. So we build foundation models for speech. So let's get into a live demo. So why don't we talk to my voice clone just for the hell of it, and just made this the other day. And we can just generate some speech. So hopefully this audio works. In the icy waters of the Arctic, scientists observed narwhals changing their heart rate to dive deep. Anyway,
Unraveling
sounds
the
like me.
mysteries of how these
We can also
unicorns of the
try.
sea can navigate the ocean's depths without the bends.
We can also try Andrew Huberman's voice clone, just for the hell of
In the
it.
icy waters of the Arctic, scientists observed narwhals changing their heart rate to dive deep, unraveling the mysteries of how these unicorns of this.
Anyway, so that's what we build. We're working towards not just text-to-speech, but speech-to-speech, like end-to-end products, stuff of that sort, also like conversational agents. And we are looking for partnerships, so if you are interested in the speech AI space, you should reach out to us. Our playground's at app.element.com. That is spelled lmnt.com. You can also scan this for the playground, as well as my LinkedIn, because we are hiring. So if you're interested in working in the speech AI space at a startup, then we're the place for you. We're a team of 7 in Palo Alto, and we are a really fun team, and we're doing some impactful work. So, yep, try it out. Message me if you want to work with us or partner in some way. Thank you.
Awesome. Thank you. All right, so we've just had our first one go under 2 minutes. Thank you very much. All right, next up we got Koi Win from Zinli. Do you prefer Koi or Danny?
Yeah, both.
Okay.
Hello, everyone. So my name is Koi from Zinli. We build on-device AI software engineers that can work on anything like chain one single line, build whole thing, or free factor, anything that you want to do. So let's see here. So we demo on Xcode. So this hello world, I can say like change hello world to hi GitHub. That's it. You're gonna see the chains. It's adaptively to any tech stack, so it doesn't need to be Xcode, Go, Scala, whatever language gonna work. You see here, I'm gonna run the app, you're gonna see. And that's it. I can say like build a classics tic-tac-toe game. That's it. So it can talk to you about the development plan, so you can like talk with it before it actually builds something to save time. Because like when I build something and you don't like, you need to prompt again and over again. So it's like a hassle. So you're gonna create a development plan for me, so I can supervise and can say yes or no. It can role play itself to the right place, like iOS developer right here. You can see. So you can force it into the place that it can make the best player for the code that you want to work on. That's it. So it tells me exactly what you're going to work on, existing file, new tree structures, anything. Just enter and see everything's just be created automatically here. Products, tic-tac-toe, model, views, logics. And it will write end-to-end code. You don't have to do anything. Hands-free. And if it makes some bug, it's going to fix. You don't have to fix. It's just right here. Just right here. This right here. Now I gotta run to see if any compile error.
All right, thank you very much.
Thank you.
Thank you. All right, let's see if we can get someone who's going to go under 2 minutes. Julian Sachs, Fine Tune.
You speaking again? Hey, everyone can hear me? Testing.
Nice.
Okay, I'll make this super quick. We launched fine-tune last week. It's the easiest way to fine-tune agents, and we don't fine-tune any models. The whole idea is that you go build out an agent
on whatever framework, you create synthetic users that reflect your clients and actually run your agents in a sandbox environment. And we actually build up a graph that represents a successful execution and a bad execution, so that when you deploy your agents into production, it performs RAG over this graph, and you can have more reliable task generations. So you can go from a small agent to a really buffed up, jacked agent. So yeah, that's fine-tuned. If you're interested, yeah, scan this.
I love that. Short and sweet.
Yeah. One more thing. So, yeah, not related to fine-tune. I'm actually working on a community project. I came to SF last week Wednesday, so really new. And it's kind of a shame to see all like the homeless and the things that are happening downtown. I'm working with the Lieutenant Governor of California. They're doing a project to, take these people and, provide them shelters and things like that. But there's not many workers to actually provide support. So we're looking to build out a community model that has this information about these services to provide support. So if you're interested in doing a contribution to this, hopefully it's open source. We'll do open source, of course, and really, help SF. It's a great city, and we need to fix something about it. So yeah, if you're interested, also, yeah, scan this QR code. Thanks.
All right, thank you.
Cool.
I love that, Julian. Short, sweet, and also public service. All right. Next up on America's Next Top Model, we have Reckon from Aditya Rohit. Aditya? Are you here? Oh, you are here. Oh, nice. Okay.
Hi, everyone. I'm Aditya. I believe most of you are developers and must have worked on API integrations in your lifetime. Some third-party, some internal integrations, and we exist to solve the problem around integrations. We enable developers to skip past documentation, get to a sample code that actually works, and implement it faster. I'm quickly going to show you this thing. This is our VS Code extension. As a developer, if you're looking to integrate PayPal's API, I'm just giving you an example. You have to go through the documentation in order to build it. With Reckon, everything changes for you. All you need to do is download our extension, register your account. It's very simple. Type in PayPal, select which API you want to integrate. Let's say orders. This also includes the language. We support 14 programming languages. The version, and then which method that you want to integrate. Let's say create order. Click, copy, paste in a file, select the line, and press enter. And you have a sample code, which is TLDR documented. It has all the information that you need in order to implement this API method. What are the mandatory fields? What are the optional fields? Where do you put in your keys? Which URLs you are going to hit? How you manage responses? And then example for it. Besides this, we also generate sample code for workflows as well. That takes a while because AI takes about a couple of minutes to respond, and we can't really do that. So when you use Reckon, you can bypass the documentation, and you can get to integrations faster. Right now, you can add any open API spec, V2 or V3, into a dashboard, generate the code for the API that you want to integrate, and get on moving. Thanks a lot.
Awesome. All right, thank you very much for another below 2-minute demo. Okay, next up we have Helicone, Cole Gottdank.
Hello? Okay, there we go. Hi, I'm Cole, co-founder of Helicone. We're an open source LLM observability platform. We launched about 18 months ago. We have thousands of startups using us at the moment. We've logged about 1.6 billion requests, which is pretty awesome. If you want to integrate with Helicone, you could do it in just a single line. So all you have to do is change that base URL, and you go through our proxy. So let me jump in. Once you integrate, you instantly get this rich dashboard. This is full of all the metrics that you need if you're building a generative AI product. You can see the cost over time. You can see your users, what are the unique users using your application, what are the latency quantiles. You can also integrate with our security, one of our security features, and be able to see all the threats detected on your application over time too. So let me switch orgs real quick. And then you can also, so once you start logging requests to us, you can go to our request page, and you can view like the actual pure requests. So if I click into a specific one, I can see the content that was sent and received from the AI. I can also see additional metadata. I can add it to a data set if I want to go ahead and fine-tune it somewhere else, maybe with the other person who spoke earlier. And then you can also use custom properties. This is a way to like segment your data by whatever. You can do complex filtering. And then you also run evaluations. You can do automatic evaluations, or you can do manual human review. So yeah, so say about 35 seconds left, don't want to go too much, but if I see this request, I don't like it, I can click right here, hop into the playground. Let's hope this is the demo curse every time. But, all right, we'll skip the playground, that's okay. But let's go back here. So yeah, that's it. There's a lot more features. You guys should check it out. It's so easy to integrate. It's just a single line. So yeah. And then we're launching on Product Hunt this Thursday, August 22nd. If you want to follow us on Twitter and be able to follow when we actually launch, that'd be awesome. I appreciate it.
Nice work. All right, we're a little over halfway through now. Next up, we have Code Flash, Sarah Mistral.
Hi all. Can you hear me? Okay, awesome. So my name is Saurabh. I'm the founder of Code Flash. So we all hate writing slow code. We all want fast code, right? But it's a very hard thing to do because it requires expertise. And because of that, a lot of the code in the world is super slow, and we don't even know about it. So Code Flash is a way to automatically optimize any Python code you write. So let me show that with a quick live demo. So imagine that I am just writing this code that just like finds common tags between like a list of articles. So simple like list comprehension, like find simple things. And because I'm a good developer, I just write a test for that as well. And then I go ahead and create a pull request for this. So what's going to happen now is I have installed Code Flash on my GitHub account. So what's going to happen is this is going to start like a GitHub action that's going to, in the background, search for optimizations for this. So what this is going to do is obviously install like the whole environment, set up Python, like install the dependencies, and then start executing Code Flash. So what this is going to do is like look at the piece of code and figure out, hey, and ask the question, like what would be the best way to write this piece of code for maximal performance? At the same time, it goes and then like tries all the optimizations and runs a benchmark for that small piece of code that you wrote and figures out the best performing code for that piece of code you wrote. So this is going to take a couple of minutes, but let's just show you an answer. So this is like what the optimization looks like. It says, hey, why don't you replace these 3 lines with this like set intersection method? So instead of like doing this list comprehension, you can just like iteratively update a set. And it explains what happened. So this one, like the runtime went from 10.2 seconds to 25 milliseconds. So that's 400x faster. And it explains like what happened. And it runs all your test cases. It also generates a bunch of new test cases for you. So it like ensures that the new code is same as before. But we're out of time, but we are used by like in production by Airbyte, Pydantic, LangChain to optimize the production code. It's like very stable. And if you want to try it out, please scan this thing. It's as simple as pip install Code Flash on your code base.
Thank you. All right, next up we have Cloud Code from Sarah Panda. I hope that your company's logo has a panda on it.
No, but hello everyone. I'm Saurav Panda, and I'm the CEO and co-founder of Cloud Code AI. And we are building an open source tool called Kaizen, which helps you find bugs in your throughout end-to-end cycle of your software development. We basically scan your code. Provide code review, and also write test cases for you so that you can build faster and actually go to production faster with confidence. So let me show you a quick example. I just created a file, and let me create a PR.
So whenever you create a PR, our system basically goes through your code, has a RAG model, so it actually understands what might be going behind the scene, like what other functions are being interacted, and if anything affects your code, the new changes. And it will give, like it generates the PR description for you at top, and then it also will generate like statistics. Hey, like I didn't find anything relevant, but it did find something. Like, hey, there is this file, it doesn't have a unit test case. So let's go ahead and ask it to write the unit test case for the new updates which we have. So what this will do is this will start writing the unit test case. It's very slow because we have a multi-agent system which takes a long time. As it says, it will take 1 minute 15 seconds according to our bot's estimation. So let me just show you how the test cases look like. I did run this before, prior to showing the demo. So Kaizen will automatically create test case and create a PR for the test case, and then you can see this is actually tested using GitHub Actions behind the scene to ensure like it's working. And just to show you another feature, like the code scan, wherein like it goes through your code and identifies all the problems. You can see them. You can understand what's the issue, how you can fix, and you can also create a task on GitHub and ClickUp. So sign up for free at cloudcode.ai and do start our repo. Thank you.
Awesome. Thank you very much. Okay. Next up, we have Komodo AI, Anish Chopra. Big shout out to the Cube team for getting this streaming, by the way.
All right. Hello. Hello. All right. Hi, everybody. My name is Anish Chopra. I'm the CEO of Komodo AI. We are building a GPU cloud built for AI teams, where not only do we offer extremely competitive GPU prices, but we offer an entire developer platform on top of it. So if you want access to a GPU machine, you just go to the dashboard, pick a GPU, select a region, and you'll immediately get access to your GPU machine. You can access it through Jupyter Notebook, or with our CLI, with one command, you can open it directly in VS Code. Now, on top of just launching dev machines, you can also launch serverless training jobs with one config file where you define your setup instructions, what GPU you want, and any commands you might want to use to, for example, fine-tune a model. With one simple command line command, you would launch this config file immediately onto a self-terminating machine. So it runs your job and terminates the machine when the job is done. In this example, I actually fine-tuned Llama 3 on a data set to get rid of its safeguards. And so in the next vertical here, I can actually serve this model, again, with a very simple YAML file. So if I go and try to ask regular Llama 3, how do I rob a bank? It's not going to tell me. But if I try to interact now with my hacked Llama 3, it will tell me, because I fine-tuned it in less than 30 minutes for under $25 on the Komodo platform. You can also connect your own cloud account to use your startup credits on AWS, GCP, Azure, and then seamlessly overflow to our cloud when you're done with your credits. You can also connect your on-prem Kubernetes cluster as well. We are aiming to be the universal developer platform for any compute, whether it's your cloud or ours. Thank you.
Thank you very much. All right, so if anybody robs a bank, we know who to go to. Next, we have...
Sorry, and also, here's our website. Me and my co-founder are around. Come say hi.
All right, if you need to go rob a bank, go find these guys. All right, next up, we got Yi Ding, who's going to talk about small to slides. Oh, Yi Ding and Elliot Kang, who is not listed.
Yeah, yeah. Actually, I had a lot of fun building this with Elliot, but he's going to do the presentation, and I'm going to stop talking. So.
All right. So we'll be talking about small to slide, which is a retrieval scheme we've been kind of playing with. Okay, so GPT-4 is out, and I think we should use it, right? So now that we can input both text and images into GPT-4o, like, what should we do? Should we just keep inputting text? Oh, I don't think so, which is why I'm here.
Pick up the mic on the stand. No, yeah.
So doing RAG on pure text is really simple. You embed the text, you retrieve the text, and then you generate a response from the text. But what about charts and graphs? If you strip the text from the slide, you'll never capture everything. In fact, you'll probably get a bunch of dashes, like the CPU server racks. All right, so this is where small to slide comes in. You embed the text, you retrieve the image, and then you generate a response from the image. So essentially, it's kind of similar to small to big in that what you embed is different from what you give to the LLM. Cool. And the way you do it is with the metadata. You embed the text, and then you keep a reference to the image as the metadata. Then you use the metadata to pull the image, and then you can synthesize a response. Cool. Okay. Yeah, if you remember only one thing from this, just remember that the content you embed with does not need to be the same as what you give to the LLM. And here's a little demo. So here's an example query of which NVIDIA customers prefer on-prem over cloud deployments. So this is kind of the textual prompt that we send to the LLM. And it does terribly. It kind of just gives very opaque details, which don't really matter. And any human can see from this little box that Dell, Hewlett-Packard, and Lenovo prefer on-prem. So you don't really capture the visual relationships, even if you just parse the image text, right? So yeah, we get the correct answer down here, and yeah, thank you.
All right. Thank you very much. Next up, we have Thomas Smoker from Waihow AI. Fun fact, by the way, Elliot and Yi are both longtime community members. Yi has given multiple presentations here.
Cool. Hi, everyone. So we are the co-founders of Waihow, and we are building data infrastructure for more structured context and more structured knowledge. And one of the most common technologies that we're using behind this is knowledge graphs. And so we're making it easier to combine workflows between LLMs, domain experts, and developers to create graphs. And so what I'm showing is our product that's currently in beta at the moment. Everything that you see in front of you is completely replicated with an SDK that we have. And some of the things that we focus on here that we don't see in the market is really very granular control over the schemas that you use to create graphs, multiplayer graph creation, as well as very modular graphs for multi-agentic workflows. So just showing what we have so far. We accept a whole bunch of file formats, so like structured and unstructured data, PDFs, TXTs, CSVs, JSON file formats. We focus very much on being able to control the schema and using that schema to control the graph output, and ultimately being able to create a graph really quickly through this process. So being able to select schema, being able to select this graph right here. And so in terms of the graph that we have, just clicking through, you can see that we believe in hybrid approaches. So you can see nodes, triples, and also the underlying chunks that are represented in your data. And you can just very easily create nodes and triples through this process in a very no-code manner. You can do entity resolution, and this has a rule-based system, so it gets smarter and smarter over time. And we also allow you to share this graph, make it public, export it to any database of your choice, and ultimately be able to query the graph. And in this process, be able to see the nodes, triples, and ultimately all the different chunks where it comes from. So you can get more deterministic, more accurate, and more auditable RAG outputs. And that's us. Thank you so much.
All right. Thank you very much. Okay, so this concludes our version of America's Next Top Model for today. There will be more presentations in September. I don't know if you guys noticed anything particular about this, but we didn't have any female founders demo this time. Last time we had quite a few. So if you have friends that are female founders that are building AI developer tools, please, please ask them to come sign up to come demo in September. We would really like to be as inclusive for everyone in the community as we possibly can. All right, guys, so that concludes the event. Feel free to stick around, chat with each other, and I hope to see you guys again.